G'day viewers. In this segment I'll talk about peer-to-peer content distribution systems using BitTorrent as an example. So peer-to-peer content delivery is interesting to us because it provides an alternative to client-server content delivery using CDNs. And it's an alternative that runs without dedicated infrastructure. That's what makes it interesting. We're going to look at these systems just to understand a little bit about how they work using BitTorrent as an example. And I'm really just going to give you a quick overview of these systems so that you've seen what they look like. So here's a little bit of context for where peer-to-peer systems came from. We've seen delivery with traditional client-server methods which have scaled up over time to become content distribution networks. These systems are efficient and they're able to scale up delivery for a very popular content, and they work quite effectively. They're also quite reliable, and that's because they're a managed infrastructure. People pay for content delivery, so you can hire people to carefully administer all of these systems and run them well and make sure they provide good service. But traditional models, this CDN system, have some disadvantages too. And the two real disadvantages that come to mind are, first, the need for this dedicated infrastructure. It has to be provisioned and carefully managed. All of that costs money. So we're paying maybe quite a lot, maybe more than we need to, for this content delivery. And second, there is an element of centralized control or oversight. Whoever has set up the CDN is really in control and able to make decisions about what goes on that CDN. Now that may present problems for some people for many reasons. You might not be interested, for instance, in some large internet companies such as Google or Facebook delivering all of your content and having a very good idea of what's going on. So if you care about privacy, peer-to-peer might be more interesting. Other people have different examples, of course, such as downloading illegal content. So for peer-to-peer, the real goal of this technology is to provide delivery without the dedicated infrastructure or centralized control that we've seen in these other systems, while still retaining the advantages that we got from the CDN. So we still want to be efficient to deliver content at large scale when there's very popular content, and quite reliable in providing a system that's really very usable all of the time and provides good performance and is always up and so forth. This all sounds great. The key question is just how on earth are we going to make this work when all we have is a pool of clients who want to exchange information amongst themselves with no dedicated infrastructure to help them? Well, the key idea here is that we're going to have the participants help themselves. The participants here are called peers in the system. That's why it's peer-to-peer technology. Peer-to-peer took off very shortly after some of the early systems, such as Napster, demonstrated a peer-to-peer system in 1999. This was really used for stealing music or downloading illegally copied music. It's since become defunct because it was shut down. There was a flurry of activity on different peer-to-peer systems, including BitTorrent was one of the fairly early ones. It was developed around 2001 and it quickly became very popular. It's probably the dominant peer-to-peer system today, and it shifts a substantial fraction of the internet content. So it really sees very widespread use. Okay, so let's just talk about some peer-to-peer systems in general, and then I'll move on to BitTorrent. So for peer-to-peer in general, for delivering content, there are a few challenges that we're going to have to deal with just because of this very different setting than client servers. The real problem we have here is there are no servers on which we can rely for anything. So this means that all of the communication to deliver the content is going to be between the participants or peers. This is why it's called a peer-to-peer system. That's the communication pattern, not client-server. So all of these peers are going to have to organize themselves somehow into a coherent architecture to accomplish the task of content delivery. Well, you might be able to work out how to do this if you just have a group of friends at a small scale. But we would like these peer-to-peer systems to scale up to large scale, hundreds of thousands of clients working together to distribute content amongst themselves, for example. At this scale, there are a few problems, and I'll just go through them here. The first problem is that of limited capabilities of the participants. So all of the participants, the peers, are just, they're clients that want to download the content too. We don't have the luxury of provisioning highly powerful, high-end servers that can distribute content to many clients or end clients. Everyone's just a client in some sense. while they may range in their capabilities, we don't have the luxury of deciding exactly who's going to be how powerful. So the question then is, how can one peer, which might not be a particularly high-end peer, be able to deliver its content to all of the other peers in the system if they want to download that content? That's one issue. Another issue is that of participation incentives. The peers are really helping one another, at least that's what we want to happen. But if as a peer all you really want to do is download the content, you want to get a copy of this file, we haven't yet really worked out why it is that you're going to bother sending copies of that file to everyone else to help them out, since that's not really what you're trying to do. And the third issue is that of decentralization. With a managed server infrastructure, you know who to contact to find out where the file is. With a peer-to-peer system, the set of peers is changing over time. It's just whoever wants to be involved in the download and spreading of this content right now. So it's not clear in this system how you would go about finding out who to contact to get a copy of the content. So we would like systems that work well when they're very decentralized. No one's in charge and all of the members of the system are constantly changing. So these are actually three substantial challenges to deal with. Well, there's roughly an approach which we could use to deal with each one. So to overcome the limited capabilities of an individual peer, we can still enable one node to distribute its content to all of the other peers by simply making a distribution tree. This is like multicasting, or really sort of like what a CDN is doing over time. So if you just imagine the source node here has content and everyone wants to get it, well, we could get it to all nodes by having the source send only 2 copies to these 2 nodes, and these 2 nodes each would send only 2 copies, and there actually I've reached all of the other nodes in the network. Let me just clean that up. Here it is. You can see by following that distribution pattern, no node did a lot of work, yet we got the file to everyone in the system. Of course, with this tree, I have a small picture here, but we could scale up to a very large number of nodes using this technique. So, and actually we wouldn't have to go through very many levels to get to a very large system because of the way we're growing exponentially. So this kind of transfer is typically done not instantaneously, but with replicas over time. So each of the other nodes that you're sending to, like here, a replica of the file, it started off here, a replica has been stored here, and sometime a little later it'll be transferred to these other 2 nodes. Now this approach means that in some sense the capacity of a peer-to-peer network is self-scaling with its size. If you have more nodes in the system, well, you have more capacity to distribute the content to all of the nodes themselves. So it certainly has the potential to be able to work and deliver content to all of the nodes. In terms of participation incentives, I'll note that the peers here play 2 different roles. The pink arrows here, like these arrows, are downloads to this particular node that's shaded in grey. Let's just call this one the peer that we're interested in looking at. So this is really the node helping itself. It's downloading the content that it wanted all of the time. At the same time, because it participates in a peer-to-peer system, this node is doing some other work. These are the blue arrows. Oh, I forgot a pink arrow there, doesn't matter. These blue arrows, from the point of view of that same node, are uploads to other nodes. These uploads don't help it directly at all. They're really doing other nodes a favor. So this is the dual roles and why it's called a peer. It's performing, if you like, the roles of both the client and the server. To encourage participation in a network, we can try and couple the 2 roles together. Essentially, we can try and create a system where nodes are working together so that one of them is sort of saying, well, I'll upload content to you if you upload it to me. If they both do that, and we can create a system that works that way, then we'll encourage a bit of cooperation and they'll all satisfy their goals. Of course, we just have to come up with a protocol to do that, and that's part of the trick. And finally, in terms of decentralization, nodes, even though the set of nodes are changing, the peers in the system need to be able to learn where to get the content. To solve this problem, we're going to use something called DHTs, a distributed hash table. Some of you might have heard of DHTs, maybe not. DHTs Started as an academic line of work in the academic community about 2001 with work on systems called CORD and CAN, you might have heard of. They turned out to be all of the rage in the networking research community. There was a huge amount of work on them, there still is. They are some of the most highly cited networking papers of all time. Now, I don't really have time to tell you how these new algorithms work. If you like, I'm sure you can read about them a little further. Actually, in your text, there's a section on the distributed hash tables in the same section as peer-to-peer systems, which will explain how one of them, CORD, works. But what I'm going to tell you now is simply what a DHT does. So a DHT is essentially an index. You can look this up for their name to find out where the peers are. That's what we want to do. Now, it's a distributed index, so the index is spread across all of the peers, and it's fully decentralized and efficient. These are the properties we want. So what does all of this mean? Well, I guess I'm repeating this a little bit, but let me just say a DHT is an index that's spread across all of the peers, so it's distributed. The index provides a mapping from, say, the name of a file or something you want to get to the set of peers who currently have pieces of it that you could contact. And any peer who's in this system is, by using the DHT algorithms, able to look up this index and find out who the peers are to contact to get a copy of this file. So an index is a very simple thing. It turns out to be difficult to do in a way which is fully decentralized. Even when the peers are changing, it is still very efficient and fast to look up. That's the magic of DHTs, but I won't go into it. Okay, so let's move on to a BitTorrent to see an example of a peer-to-peer system. So BitTorrent is the main peer-to-peer system that's in use in the internet today. It was developed starting in 2001 by Bram Cohen. Here he is, shown on the right. Finally, we found someone younger than myself to show you a picture of. That's great. BitTorrent, after its introduction in 2001, grew very rapidly, and it sends a very large amount of traffic because it's used to transfer very large files. Movies, for instance. Copies of movies are moved around. As a result, today, BitTorrent traffic constitutes a significant fraction of all internet activity. So this is one of the main kinds of traffic on the internet. And it's used for much legal as well as illegal content. Maybe I should actually say illegal and legal content, depending on what you think is mostly transferred with BitTorrent. So just to switch to a little closer to the BitTorrent terminology, data is delivered using these things called torrents. A torrent, you might imagine, is just a big gush of data that's going to give you the file you want. The BitTorrent system transfers files in pieces, so it's going to break up a file into pieces. Because by using many pieces in parallel, this parallelism is what is going to give us a high level of performance and let you get a fast transfer rate, even though the individual peers might not be very fast themselves. It's notable for its treatment of incentives as part of the protocol. What this really means is that the protocol does actually consider incentives and try and do something about it. We'll see that in just a minute. And in terms of decentralization, some of the early versions weren't really decentralized. They used an index which was stored on just another server that you had to find and know about. But the most recent versions have now switched to using decentralized indexing technology using a DHT. Okay, so here's the architecture. Oh, sorry, actually, before we get to the architecture, here's the steps to download a torrent. And then I'll show you a picture and we'll go through these steps again. This is what you do. Step 1, start with the torrent description. You've got to know what you want to download. Maybe someone, your friend, mails you a link or a description of a torrent and says, check this out, it's great. Okay, once you've got this description, step 2 is to find out the peers you can contact to get the torrent, to download the file. You can do this either by contacting this special tracker to join the set of live peers and get the list of other peers that are currently downloading the file. This list will contain at least a seed peer, a special node which is initialized with a copy of the content to bootstrap this whole process. This is the older centralized way. Alternatively, you can use this decentralized, fully decentralized DHT index, look it up under the name of the torrent and find a set of peers who you can contact to get a copy of this file. Now you know who to contact, the peers. And what you begin to do is start trading pieces with them. These peers, everyone's trying to download the same file at the same time, so everyone trades or swaps the different blocks they have. As you contact different peers, they may have some different blocks, and you may have some blocks they want. So you begin to trade them until you get the complete file. And as you do so, the incentive rule is that you're going to favor peers that upload to you rapidly, and choke peers that don't upload to you rapidly by slowing your upload to them. So somehow you're providing a little bit of feedback. People who are helping the system by downloading to you, well, you'll also provide them good service. People who aren't really helping you, going to try and cut off service to them. That way, if they're not helping anyone in the system, no one's going to give them good service. I've talked about that a little bit through the steps, but I think they'll become clearer when we just look at them a little more and talk about how they solve the challenges. So here is a peer-to-peer system, and you can see I've circled one peer we're going to look at, but all of these other nodes are peers too. Peer, peer, peer. So all of these peers are trying to download the file, receive the torrent that is, at the same time. So they all have the same goal in mind. One of them here, the seed peer, already has a special copy of the content. That's to get the system going. Someone has to have the content after all. Now in the initial versions of BitTorrent, the way it works is once you have a description of the torrent, it's metafile that just says what it is you're trying to download. In this, there is information about who the tracker node is. If you then contact the tracker node, what's going on here? You can get the list of live peers. So that will have like 1, 2, 3, all of these nodes. It will tell you who they are, so you know who the peers are. And then you proceed with the BitTorrent protocol. You contact a randomly chosen set of peers, like maybe these peers, to trade chunks with them. You'll ask what pieces of the file they have, and then you will try and download those pieces from them, and they will also be asking you what pieces you have. And as you're talking to multiple different peers, you'll get multiple different pieces, and you'll be able to trade them with other pieces. And this way, everyone will be helping everyone. And some peers eventually will leave this system when they have the new file, but other peers will arrive. Especially if many peers are trying to download at the same time, there'll be a large set of people available to help everyone else. So let's just revisit those challenges and see how it all works, how we've met them. In terms of dealing with the limited capabilities of an individual peer, we've dealt with that by dividing the file into pieces that can be downloaded in parallel. This peer here that we're looking at is downloading from 3 different other peers concurrently. That means if these other 3 peers are very wimpy, well, we're able to get a download from all of them. So the rate at which we can download is the sum of this. It can be quite fast. Our infrastructure can be providing us a fairly good rate because of this parallelism, even though the capabilities of each individual peer is limited. In terms of participation incentives, I talked about this technique of favoring the peers which are uploading to you, you upload to them. On the other hand, we choke peers that aren't uploading to us. So this peer here, this unfortunate peer, is shown as choked by all of the other 3 peers it's talking to. It's these stops here. This is the choking. And this other peer must be choking because the rotten peer here with the X's, I'll say rotten, not really helping out, or unhelpful might be better. This unhelpful peer is not providing downloads to all of the other nodes. And so they've cut it off, and they're favoring other peers. This is going to provide an incentive for everyone who has any content to trade to actually trade it. If you don't have anything because you're just beginning, other nodes will give you a basic level of service, but your download will take a very long time unless you're willing to help everyone out. Okay, and finally, in terms of decentralization, well, when we switch to the fully decentralized model, the DHT index is spread over all of the peers. So a small piece of it you can see here is implemented as part of every peer. Together, they are implementing this DHT, this overall index, using the DHT technology. So any peer that can find another peer can join the system and look up this index, and will end up carrying things to form part of this index. So it's fully decentralized, and we've made our goal of knowing how to get around without having a well-known central server that provides information. Okay, so that's peer-to-peer systems, and BitTorrent is an example. Peer-to-peer systems are interesting to us as an alternative to CDN-style client-server distribution of content. They certainly have some potential advantages if they can do away with dedicated infrastructure and decentralization. They also have some challenges to meet to do that. It's probably not as easy with peer-to-peer technology as it is with a managed, carefully provisioned infrastructure. So if we can make it work, we're in good shape. But there are still some problems to solve to make them work very effectively. At this stage today, CDN technologies are probably more mature. Nonetheless, P2P technologies are coming along, and DHT technologies too, and over time we're finding that they're more widely used in systems. And these are the technologies that are adopted in different kinds of content distribution systems. Actually, P2P and DHT style technologies are used as part of the Skype system and as part of Amazon's system, Amazon's cloud computing services. So I think in the future what you can expect is more and more hybrid systems which maybe use some peer-to-peer style techniques along with a carefully provisioned infrastructure, for example, rather than having solely all of the clients do it themselves. Okay,